Hey there y'all, today we're going to start Unit 2 on solving equations and inequalities. Over on the right hand side you'll see the layout for this chapter, for this unit. We'll start with 1 and 2 step equations including problems with fractions. We'll look at solving multi-step equations and with equations with variables on both sides. And end up with solving literal equations, that's equations that have a lot of variables in them. And then we'll move into the second half of this unit and talk about solving inequalities with 1 step, 2 step, variables on both sides, and eventually in the final section on compound inequalities. So that's the roadmap for where we're going to be. Again, expect a quiz on each of these after every second lesson. All right, so let's look at 2.1 on solving 1 and 2 step equations with fractions. And so the objective will be to solve those 1 and 2 step equations. And our standards come from AREI 1. And that's to understand and justify the steps taken when solving simple equations in one variable and create new equations that have the same solution as the original, and be able to solve linear equations and inequalities in one variable, including equations with coefficients represented by letters. And again, that's getting us as we go towards section 4. So let's talk about first what is an equation, and let's talk about this definition. So an equation is a mathematical sentence that has an equal sign. That is the biggest key when we talk about equations. It has to have an equal sign. And so what does it also have to include? It has to include numbers, operations, and or variables. And remember, just like when we talk with expressions, we can have numerical equations like 2 plus 3 equals 5. Or we can have algebraic equations like x plus 12 is equal to 7. And so let's talk about the steps of solving an equation. We look at this simple problem here that's already worked out for us. X plus 12 is equal to 7. And so to solve an equation, remember that we are going to isolate the variable. When we talk about isolating the variable, we're trying to get this x by itself. And so the problem says x equals some value on the other side, or whatever variable we're dealing with. And so we have to deal with inverse operations. So let's talk about that definition. So an inverse operation is an operation that undoes a given operation. So what does that mean? If I see subtraction, I'm going to undo it with addition, because subtraction is the inverse operation of addition, and vice versa. Addition is the inverse operation of subtraction. Multiplication and division also work that way as well. That division is the inverse of multiplication, and multiplication is the inverse of division. So again, we're going to use operations to undo what we see to be able to get the variable isolated and by itself. So as we look at the problem here in the screen, x plus 12 is equal to 7, we see our variable is x, that's what we're trying to get by itself, is being added to 12. And so to undo it, our inverse operation is subtraction. And so what I do to one side of an equation, we have to do to the other to keep it balanced. And we're going to talk about those properties in a moment. So I'm going to subtract 12 from both sides. 12 minus 12 is 0, so that cancels. And 7 minus 12 is negative 5. And so we get that x is equal to negative 5. And so that is our solution. So let's talk about that definition of a solution. So a solution is a value for the variable or variables, as we get into multivariable problems later on, that will make an equation or inequality true. So what does it mean to make an equation or inequality true? Watch what happens on this problem. We found that x is equal to 5 here. If I substitute this negative 5 back in for x here, so I would rewrite it as negative 5 plus the 12 is equal to 7. And remember, anytime you substitute, always use parentheses. Start with parentheses and work from there. And so negative 5 plus 12 is equal to what? 7. And is 7 equal to 7? Yes. So that is a true statement, which means that the x minus 5, or sorry, the x equals negative 5 is our solution of this equation. Because if I tried a different value, let's say I try x is equal to 2. Well, 2 plus 12 is 14, and 14 is not equal to 7. That's not a true statement, right? 14 does not equal 7. So we have to find the solution that is going to give us a true statement. And so common mistake that happens here, this is our solution, x equals -5. This is our check work. This is not our solution. This just verifies that this answer is correct. And let me tell you this, if you will do the check work on every single problem that we do in this unit, you can guarantee that you have every answer right. But if you refuse to check your own work, please don't at me later when you're like, I don't get this. Check your work. If you'll do it, you'll get it right the first time. All right, so let's look at the properties of addition, subtraction, multiplication, and division as it deals with equality. So the verbiage here says this. I've got some variables here that can be any value, any real number. And if I have the statement that A is equal to B, then I can add a value to both sides of that equation, or I can subtract that value to both sides of the equation. And as we see down here in multiplication, I can multiply both sides of the equation by the same value, or I can divide both sides of the equation by the same value. So let's talk about what that means. Now, of course, we cannot divide by 0. That's the only exception there. Otherwise, I can add 0 to both sides. It's still equal. I can multiply both sides by 0. It's still equal, right? But I can't divide by 0. That's the only issue. So what does that mean when we talk about solving equations? So let's look at that below. When we solve equations with 2 or more steps, we have to undo, right? We talk about undoing what was done to the variable. And so when we think about a problem, and we'll look at some examples below, we've got a few, that if I've got multiple operations, I have to undo them like I unpeel an onion, right? So if I were to like make my bed, right? Think about making your bed, right? You put your sheets on the bed first, you know, the fitted sheet, and then you put the regular sheet, and then you put the comforter, right? And then you put your pillows. Well, if you're going to undo everything, do you pull the fitted sheet off first? No, because everything would get messed up, right? You have to do what first? Pull the pillows off the bed. Then pull that comforter and the sheet, and finally you're down to the fitted sheet to unmake the bed. And so that's the same thing we have to do. We're going to use our order of operations, but we have to work backwards. And so when we talk about our PEMDAS, right, our order of operations, we're used to going down the order of operations. But we will only do that if our directions are to simplify or evaluate. When we're asked to solve, we will reverse this process and first look at getting rid of addition and subtraction first. So let's look at some examples and see this in action. When we look at example 1 here, x over 8 is equal to 13. We want to solve this for x. And so one thing I would recommend, highlight what you're trying to isolate. And if there's multiple instances of that x, which we'll look at later on in this unit, then we want to highlight all the instances to get them together. And so ask yourself, what operation is this? What is x over 8? What's that operation? It's division. So how do I get rid of division? What's the inverse operation of division? It's multiplication. So when I do this problem, x over 8 equals 13, to undo the division, I have to multiply both sides by 8. Now, on the left-hand side, that'll cancel. This 8 and this 8 cancel because multiplying by something and dividing by the same thing will get you 1. So it cancels those out. 13 times 8 will do that multiplication. That is going to be 104. Okay? And so in the end, we get that x is equal to 104. That is our solution. Now, how can we check our solution? So we substitute our answer back in. We're going to take this 104, plug it into every x that we see, and see if it works. So I get 104 divided by 8. Is that equal to 13? Well, go to your calculator, do 104 divided by 8. Remember that 13 is equal to 13, so it checks out. So let's take a look at example 2 here. We have got negative x over 5 is equal to negative 8. And so same idea here. We can remember that with that negative, I can apply that negative to the numerator and write it like this. I can apply it out front like so to the entire fraction. Or I can apply it to the denominator. And in this case, I'm going to go with this last case because the x is what I'm trying to isolate, right? So if I want to isolate it, I want to get everything away in as few steps as possible. And so I'm going to rewrite the problem as x over negative 5 is equal to negative 8. And so like example 1, what do we need to do to undo this operation? Remember, first think about what operation we see and what operation we need to undo, right? To undo that first operation. So what do we see? We see division. And so to undo division, we do what? Multiply. And what am I going to multiply both sides by? It's the negative 5. And so what is going to happen? Again, the negative 5s on the left-hand side are going to cancel because that's the whole point, right? If I multiply and I divide by the same value, they cancel. And on the right-hand side, negative 8 times negative 5, negative times negative is a positive, and 8 times 5 is 40. And so that would be our solution. We want to check our solution, so we're going to take this 40, plug it back in for x, and so we're going to get the negatives out front. 40 over 5. Is that equal to negative 8? And so 40 divided by 5 is 8, so we get negative 8 equals negative 8. That checks out. So again, show your work, show your steps, show the check. If you will do this on every problem, you will get these right, I promise you. But you've got to do the steps, especially as we get to more complicated problems further down the line. All right, so let's look at example 3 here. In this one, we've got to solve 1/2 x plus 7 equals 11. And so remember to use PEMDAS, right? Use our order of operations. But we're not going down, we're going up because we're undoing everything that's applied to the x. And so we're going to highlight our x. So there it is. And remember, we're going to get rid of addition and subtraction first. And so what is added or subtracted to the x? That's the 7 here. And so we're going to subtract 7 from both sides. And so we get 1/2 x. That canceled for us. That's the whole point. Equals 11 minus 7, which is 4. Now, here's the next step. I need to get rid of this fraction. How is the fraction attached to the x? Well, remember that when a number touches a variable, it is multiplication. And so how would I get rid of multiplication? We do it by division. But if I divide fractions, remember that to divide fractions, like 2/3 divided by 5/7, go back to like 4th and 5th grade math for a second, we're going to do this. We're going to keep this first fraction, right? We're going to change this division to multiplication. And then we're going to do what with this fraction? And I know a lot of you are going to say flip! And that is what you were taught in middle school. But I want to teach you a new phrase. Division of a fraction is just multiplying by the reciprocal. And I want you to know this phrase, multiply by the reciprocal. I don't want to hear KCF or keep, change, flip ever in my class, because that's not the proper terminology. Y'all get it messed up on so many things that's like, oh, we keep, change, flip. No, you don't keep, change, flip on that. Multiply by the reciprocal. It tells you what operation you're doing and what you're doing to that fraction. So, what am I multiplying by? I'm multiplying both sides by the reciprocal. And so that's 2 over 1, which is just 2. And so this will cancel this because 2 times 1/2 is 1. And so I get the x. And 4 times 2 is 8. So, can I check my answer here? Absolutely. We plug this back in. We substitute it in. And so 1/2 times the 8, 7. Is that equal to 11? Well, what's half of 8? 4. And 4 plus 7 is 11, so it does check out. So x is equal to 8 is the final answer. Okay? So that's what we have there. So here's example 4. Negative 2/5 x minus 9 is equal to 21. And so I'd like you to pause the video here and try this problem on your own. Remember to use PEMDAS and remember your steps. And look back at examples 2 and 3 to help you along the way. And so again, pause the video here now and try this problem out. Alright, I hope you paused it out. And so let's look at the steps that we need to do. And so first we need to identify what is the variable. It's x. We only have one of them. And so we're going to use PEMDAS. Working backwards, what are we going to get rid of first? The subtraction that's here, right? So we're going to add 9 to both sides. Remember, what you do to one side, you have to do to the other. And so we get negative 2/5 x is equal to 30. Now, how do we get rid of this negative 2/5? Remember, it is attached by what operation originally? It's attached by multiplication. And so to undo multiplication, we do what? Division. But if I'm dividing by a fraction, we're really going to multiply by the what? Reciprocal. Okay, so we're going to take this and multiply both sides by the reciprocal. So it means that I just take the fraction, I do what to it? Flip it, right? And so that is going to be negative 5/2. So I'm multiplying both sides by negative 5/2. The left side will cancel. That's what we wanted to do. Negative times negative gives us positive, and 5/2 times 2/5 is 1. And so on the right side, what we get, 30 times the 5 is 150 over the 2. Because remember, this 30 is like being over a 1, right? Because remember, we don't multiply the 30 to that denominator as well. Don't do that. Don't do it. I see you trying. Don't do it. Okay, so positive times negative is a negative. Don't forget your sign. And what is 150 divided by 2? That would give us negative 75. Again, how can I check this answer to make sure this is right? We're going to substitute this back in. So we're going to take our negative 75, plug it back in here. And so negative 2/5 times the negative 75 minus the 9, is that equal to 21? Okay, so same thing we did with the fractions over here. 2 times 75 is 150. Negative times negative is positive, so that's 150 over 5 minus 9, 21. So what's 150 divided by 5? So that is going to give us 30 minus the 9. And so 21 is equal to 21. So that does check out. So as we move to example 5, here's our next problem. We've got x plus 3 over 5 is equal to 7. What operation's a fraction? Division, right? So let's talk about how we're going to deal with this. The x is here, right? And our order of operations would say that I normally get rid of addition and subtraction first. But the problem is it's contained within a fraction. And so here's what you need to think about when you see a fraction like this. You have to treat the numerator and denominator as if each piece was in a parenthesis. Now the denominator doesn't need one here because it's just a single number. But the numerator, we definitely have to think of it as being inside a parenthesis. And so my first step is not going to be to get rid of the 3. It's going to be to get rid of the 5 that is attached by division. And so how do I undo division? What operation, y'all? We're going to get rid of it by what? Multiplication. So I'm going to multiply both sides by the 5. And this will cancel this. And that leaves me with the x plus 3 here. And 7 times 5 is 35. Now I'm down to just x plus 3, and so now I can get rid of that final step. So subtract 3 from both sides, and we get that x is equal to 32. Again, check your work. We're going to substitute this back in for the x. So I get 32 plus 3 divided by 5. Is that equal to 7? So again, we treat the numerator on its own. 32 plus 3 is 35 divided by the 5. 35 divided by 5 is 7, so our answer checks out. So the answer is that x is equal to 32. All right, final example of just ones dealing with numbers and variables here, and then we're going to have a word problem after this. So example 6, 5 parentheses x minus 4 is equal to 55. And so with this one, remember that when a number touches a parenthesis, or a number touches a variable with nothing else in between, what's the operation? It's multiplication. And so we can do one of two things on this problem, and I'm going to show you both. So I'm actually going to do this problem twice. One example by getting rid of the multiplication first. The second by dealing with the parentheses and remembering that I can do what with the 5? Distribute it. So again, I'm going to do this problem twice. I'm going to show you that the answer will be the same both times. So we're going to distribute first. And so I'm going to get 5x minus the 4. Sorry, not minus 4. 5x minus what? I got to multiply the 4, right? 20 is equal to 55. And then now I do my order of operations, so I'm going to add 20 to both sides. And so I get that 5x is equal to 75. And I can divide both sides by the 5. And x is equal to 15. Okay, so we got x is equal to 15. We'll check it in a minute once I do the other side, and we'll do the check when we see that it's both 15. So the other method here is to remember that this is multiplication. And so to undo multiplication, we do what? Division. And so I can divide both sides by the 5. This will cancel this. And so I get x minus 4 is equal to 11. And then I can do what? Add the 4 to both sides. And when we do that, I get that x is equal to 15. So you see that the answer is the same for both. When we substitute in the 15, here's our check. And again, we got the same answer, so I only have to check it once. 5 times 15 minus 4, is that equal to 55? So 5 times 11. And yes, 5 times 11 is 55, so that checks out for us. So again, make sure you're checking your work. If you're not checking your work, you don't know that it's right for sure, and that's what's going to cause you heartache on quizzes and tests, not checking your work. Being like, Mr. McMillan, did I get this right? You would know it before you even submit the quiz or test to me, or even the assignment to me, that you have it right or not. Okay, so that's what we have there. We're going to look at one word problem, and then so if you're looking in your notes, you're going to see there's an example first about a sprinter in the Olympics. I've skipped that example and moved on to the second example here. As a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot, and that's the abbreviation for it there. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Find the depth of the water at which the diver experiences 8,517 pounds per square foot of pressure. And so we need to understand what we see in this problem and how we're going to relate it through. And so we first know that they start with how much? 2,117 pounds per square foot. So the 2,117 pounds per square foot, let's keep our units, right? And then the pressure increases at a rate of 64 pounds per square foot per foot, right? And so we're adding pressure, right? It said it increases. Remember the words we talked about in Unit 1. Increases at 64 pounds per square foot. That's the units. For what? Each foot. And so D is going to represent my depth. Okay? Because this unit would actually be pounds per feet cubed because of what we're doing. And so then this is equal to our depth that we're trying to get to, and that is 8,517 pounds per square foot. And so again, a lot of times we're going to drop these units. They are important, but just to solve it, we drop them a lot just to get through the nitty-gritty. So how do we solve this? Same thing like the rest, right? So I've got the D here. So what needs to move first? It's not the 64 because that's attached by multiplication. It's this 2117 out here. I've got to subtract that away first. So subtracting 2117 from both sides, I get 64D is equal to 6,400. And so now I'm going to divide both sides by the 64 because I'm undoing the multiplication. And so D is equal to 100. Now, our D is in what units? Well, we're diving at what? In feet. So what is his depth? He has a depth of 100 feet. And again, remember that word problems require what? Word answers. All right, I know this video was a little long, but this is a lot of review information as well. This should have been from 7th and 8th grade. So I want to make sure that we're hitting the major things you need to remember from solving equations. So that's it for this video. Again, make sure you do your Google form and make sure you submit those questions that you have if you have any from this lesson, and then I will see you next time.